ecosystem of business measurement assurance. Paper published in JETA about a year ago, or maybe even less than that. And so what I was saying is that the blue things, the dark blue things, or purple, are basically different sources of data that basically are created for one reason, and they can be used for other reasons. Give you an example. Data in the pharmacy, when you just order a drug, is basically designed for provisioning the drug and the drug. However, the information that you bought that particular drug might have been useful for many other sources. Okay, so that pictures of a parking lot, weather data, and etc. all are what we call exogenous, meaning external data that are not part of internal data of a corporation. We call in. And basically, these are not designed to work together, but modern technology allows them to work together and provide a whole set of functionalities that were not imagined with the creation of that data set. And so in order to make them work together, what you really need is an effort of integration and taxonomization. Taxonomization means creating categories, black and white, or 1 and 0, or some kind of hierarchy 1 to 5, or extraction of text out of tweets, all kind of different ways that you classify the data and bring it into some usage. And then once you have that data and the data integrated together, you basically throw apps at it. And this is the thing that I will talk several times in the semester, is about piggybacked apps. If you pick up your cell phone or you pick up your laptop, you have the hardware. On top of the hardware, you have some kind of operating system. On top of the operating system, you have a database. On top of the database, you have all kinds of extraction routines. On top of the extraction routines, you have what I call piggybacked application, one on top of the other, on top of the other, or side by side on the other. So you open your laptop, you have all these little icons sitting on the screen that can do something for you. But if you think about those icons, they are using a whole set of logic and functionalities built on below it. And the other thing to understand is that the depth of these layers, piggyback layers, is very deep. And so the whole idea that you could have systems that are really clean and have no susceptibility to hacking is kind of preposterous idea. Just to think that there are millions of lines of code on Windows or below Windows, and these lines of codes are constantly changed, and that many of not only the Windows applications, but the ones that work on top of that and on top of that are basically applications that have backdoors. If you turn your computer on in the morning, you see that some of those applications self-updated. So all these things together create basically a layer of data, of sets of data and applications with millions and millions of lines of code. And much of the code these days is public code, that there are these receptacles, there are these locations that you go and pick up code to put your application so you don't need to write it. And those pre-applications or these pre-codes basically could have backdoors or could have weaknesses that would allow you to penetrate the code. So this whole idea of piggybacked applications is something that have to stay in your mind, because that's the world of the future, and the idea that you're going to have a system totally integrated, no holes. I call these, the analogy I use is Swiss cheese, is basically some kind of contexture full of holes. And so that's something to be understood. However, when you use these applications, the functionalities are very useful, and every day someone creative creates other functionalities for you to use. We are basically thinking about related to accounting, related to audit, but soon you're going to be seeing that very difficult to sequester, to separate just accounting or something. So let me just read you what it says. A data ecosystem is a collection of infrastructure, analytics, and applications used to capture and analyze data. The term ecosystem used because rather than environment, because real, like a real ecosystem, that ecosystem intended to evolve over time. And of course, they function together, and they have inconsistencies among them. Okay, and now this talks about external data, and these are examples of what we call exogenous data that companies are using today. I'll just read you one of them. A credit union personalized marketing offers for members based on customer profiles developed with the aid of external data. And what are they using? Traditional consumer demographic data, age, gender, address, etc., social media data, geolocational data. I'm going to give you two examples just off my cuff here of research that we are doing that uses exogenous data. One is that was the PhD dissertation, and now is an article by Hyun, now a professor at Clark College. Actually, she's a professor at the University of San Francisco, but she's moving to Clark. And basically what she's doing, she picked up data of a very large retailer that you all know, with about 2,000 outlets around the United States. And she wanted to predict sales per outlet. Why she wanted to do that? So you can do predictive audit. You predict what's going to be the outlet sales and compare it against what they declare it was. If the difference is very large, either your prediction model is bad or they are cheating on the numbers. And what you obviously want to find out is if they are cheating on the numbers. So what she did originally, she created one model for all the 2,000 outlets. And that was okay. Then she'll use clustering and created sectors. And the idea behind that was that, you know, Florida is different from California. And she basically let machine learning, in this case, clustering, which is an unsupervised machine learning method, basically break the stores down into groups that were similar. I was expecting Florida companies, Florida stores to be in one group, New York stores to be in another group, and turned out that they were reasonably geographical, but not very much. Some of the Florida company stores actually acted very much like Northwest companies, stores. And there were in the Midwest stores that were like the Florida stores. So we created these clusters of stores. And then instead of having a model being for the entire United States, we had the models for each one of the clusters. That substantially improved the results. Improve the results means what? It predicted reasonably well what the sales would be of a large number of the stores. Then what we did is we kind of used the zip code of the store and added local economic data, microeconomic data for the region, for the locality, for the municipality. And that improved the results. But then we thought about it a little bit more and realized that this particular store, set of stores, sold items that were extremely weather sensitive. So it's like construction type of materials. And for example, in Florida, you're worried about hurricanes and heat. In New York, you are worried often about snow. In the Midwest, you're very, very worried about hurricanes. In California, it's a whole other set of worries like fire and et cetera, et cetera. So we actually struggled for a while in because the amount of external data on weather is enormous. So we struggled a little bit. Finally, we chose weather with some help of the meteorology department in New Brunswick. We chose the variables to be used there, and the results continue to improve. So what is the story behind that? We use exogenous data like weather, like microeconomic data for the zip code, and we use clustering analytical method to put similar things together to predict sales of stores. And then the company can do predictive analytics. They do projections for 2,000 stores, come up with these projections, compare these projections to what management is declaring that the sales for that store was, and if the difference is very large, is a proxy for discrepancy. So you examine that. So what did I basically describe? I described the usage of internal and external data in a predictive audit. And then the next thing is, how do you link external data to internal data? So you have, how do you link different types of data together? So there is this, what we call the deterministic linkage, is when you are doing, for example, relational database, and you have a primary key, something like employee ID. So you have two tables, you link them by employee ID, number of hours worked with an employee number. Now, there is other situations where you don't really have very nice matching, and in particular with exogenous variables, you most of the time don't have matching. Why exact matching? Because you didn't. One was not designed for the same reason of the others. So you need to do a lot of pre-processing and pre-filtering to come up with variables that can map to a certain way. So basically, if let's suppose you created text, you are looking at text, and you clustered similar text together, and in this text there are bundles of keywords that you can use, and then these words were words saying company is doing well or company is doing poorly, and then you pick up the 10 Ks of the company and apply a machine learning technique called sentiment analysis to tell you if the hidden message in the analyst meetings is a positive one or not, or they are just lying to you. And actually, Professor Moffat, who is our guru in text mining, has done several studies in the area of detecting if you are being lied to, or detecting if a statement is not really being very accurate. Okay, and so we finish up with several layers, a whole set of data that some of that is internal, some of that external, some data of operations, which is all internal, and then analytics around it. Applying it for a whole set of different purposes. And so you have several things that you can put together. You can put together this thing, the robotic process automation that you learned a little bit about, and maybe even with some modules that do some intelligent type of things, like identifying pictures, like identifying words, like counting things, and you put them in a robotic process automation type of frame creating an intelligent process automation. You can use what we call supervised learning and have a process that had outcomes, look at variables that are related to it, link the two of them together, come up with formulas that predict behavior, even if you don't know exactly what the relationship. And the third part of it is this idea of blockchain. We're going to talk much more about blockchain, but I'm going to mention it now. A blockchain is basically a sequence of blocks that basically have very good characteristics not to be breakable. And therefore, let me just read you what it says. Blockchain is essentially an append-only linear transactional database that is distributed and decentralized. And we are going to talk more about that at this moment. You just think it's a stream of data that people cannot go back and adulterate it, because the moment they do that, the entire blockchain becomes incorrect. So it's detectable, and there are methods to keep the integrity of this. So these three together, automation, like robotic process automation, machine learning, and blockchains will cooperate in developing this modern world of accounting and auditing, which we call the ecosystem. I want to give you an example that is at this moment just starting. We are talking with the state of Santa Catarina in Brazil, which is in the south of Brazil, and what they want to do is create an open system of contracts. So what does that mean? Is that the government buys something from any merchant, that contract will go on the system. And it needs to have integrity, because they don't want the vendors or someone else to adulterate the contracts. At the same time, they have another effort, which is an open data effort. They call it the portal of transparency. And so the second part of this effort is creating an overlay. Remember, piggybacking, an overlay on top of this blockchain that they are planning to develop that will reveal summary of this information, copies of contracts. We still don't know exactly what we are going to reveal there. But it's a two-layer idea, and many other layers can be added to it. Many apps will be added to it. So that would be an application linking machine learning and blockchain. One more thing, they are also thinking of basically simplifying a little bit their procurement and replace a lot of keystrokes on the building of the contracts by automation using robotic process automation. Now, would they use machine learning? Eventually, they will have data in a way that you can try to integrate, taxonomize, and create optimization routines. Maybe people will use it to determine the value of the bids in the contracts and say, what is a winning bid according to this machine learning routine? Very interesting, but it's many, many layers. Each one has their own complexity. And so actually this is an accounting ecosystem with endogenous internal data, exogenous external data, and components, data analytics, robotic process automation, and some AI modules. Okay, and the difficulty is in every level, but you can do simple things like starting by counting cars in a parking lot or something simple like that. And you expect improvement in efficiency, better analytics, and identification. And so the challenges in the ecosystem is you have to kind of understand the difficulties that you have with preparing your data. Accountants and auditors are not particularly data experts. You guys are going to be much more than the normal professionals. Then many of the rules for professionals basically don't apply very well. And then you have to integrate traditional system with modern system. And then we need to create kind of a feeling for ethics, like Ivy talked to you last week. And so this is actually a graph showing the same story, but the one innovation in here is the second layer from the top, intelligent agents acting upon a mirror world. First is terminology, which we already talked about it last class, the mirror world. What is a mirror world? Is a representation of the real world on electronic form. So Google Maps, which was my example, is a mirror world. And financial reports, in one sense, are a mirror representation of the actual operation of the firm, although very limited. And so the ecosystem is a mix of endogenous data, exogenous data, and AI working on top of it. Okay, and then as a conclusion of this, and you'll see in a second why I'm talking about this, is about future research, is that what I said, I showed you a slide before that I say always, the rules for taxi don't apply well for Uber. The rules for hotels don't apply well for Airbnb. The rules of the FASB and of the PCOB don't apply very well for the modern technology and for modern corporate behavior and for modern corporate record keeping. And that needs to be changed. So the societal rules, laws, and regulations will limit things. The integration of external and internal data, very important. And we can pontificate a lot about what the future is going to be.